Okay, we are going to continue chapter number 6, the link layer and lanes. Okay, so in last class we have discussed chapter number 6, multiple access protocol, FDMA, TDMA, random access protocol taking turn. Okay, so in this class, but we mentioned that we will discuss ARP and Ethernet, but we couldn't find the time to complete these two topics. So now we are going to discuss these two. Okay, so in today's class we will discuss MAC addresses, ARP and Ethernet header. Okay. So let's start that as we know that at the link layer we are using MAC addresses. We are using MAC addresses. Okay. So basically MAC address it is used at the lane at the link layer. Okay. So we have already discussed an IP address. The IP address it was used at the network layer. It was used at network layer and it was 32-bit. IP address was 32-bit and it was used at the network layer, and each network interface it has an IP address. Okay, so it was used for layer 3 network layer forwarding. Basically an IP address it identifies a host, a machine over the internet. Okay, so we also have another type of address that is called MAC. This is also called LAN address. This is also called physical address, and it is also called Ethernet address. Okay, so this MAC address its function is it is used locally. It is used only at link layer, at the LAN. Okay, so it is used locally to get from one interface, from one LAN card to another physically connected interface, and you and on the same network or in the same IP addressing sense. So the 32-bit IP address it was basically in hierarchical. First byte dot second byte dot third byte dot fourth byte. Okay, so there are two parts of IP address: network part and host part. So we have discussed it thoroughly. Okay, so the MAC address it is 48-bit. MAC address is 48-bit, and this is often burned in NIC ROM. So it is hardware burn. It cannot be changed. The IP address it is done. It can be changed. It is in software. You can change it. Okay, but the MAC address you cannot change it. But sometime in it is also software settable. Okay, so we have already discussed that the MAC layer it is implemented in the NIC and hardware, so you cannot change it. And each NIC, each link has its own NIC. For example, Wi-Fi it has its own LAN card. The coaxial cable it has its own LAN card. The fiber optic it has its own LAN card, because each has its own protocol, and for each protocol is implemented in the LAN card. But we have also discussed that it is possible that some functionality is of the MAC layer implemented in software and some is implemented in hardware. So the MAC address it is often implemented in hardware and is burned in the NIC ROM, so you cannot change it. But sometimes by software you can change it. And this 48-bit MAC IP address it is written like this way. It is flat. First byte dash second byte dash third byte. The IP address it is often written in decimal form, but the MAC address it is often written in the hexadecimal form. Okay, so it is flat. It is not hierarchical. There is no network part or host part. Okay. So now we are going to for each, as we know that the LAN card or adapter it connects the host with the link, and we assign the IP address to the interface card. Similarly, we also each interface card has its MAC address, and this MAC address is used to identify this interface over this LAN, over this local area network, over this link. Okay, so each adapter on the LAN, it should have unique LAN address, it should have unique MAC address. If it is not unique, then there will be confusion. For example, if in a class there are two students with the name Aisha and the teacher called Aisha, so there will be confusion which one is has to respond. Okay, so similarly in here, if the MAC address or the IP address they are duplicate, then there will be confusion. It may happen that the data distant for one, it will be delivered to another. Okay, so each LAN card, it has MAC address. Similarly, as each LAN card has IP address, similarly each LAN card has MAC address. But this MAC address, it is written in the hexadecimal form. Okay, it is 6 byte 48 bit. Now, as we have discussed that the IP address, it is allocated by who? By ICANN. IP address is assigned to an organization by ISP, from whom we get the internet, and where ISP gets the IP address from ICANN. Okay, now how the MAC addresses are allocated? So basically the MAC addresses allocation, it is administered by IEEE. Okay, it is an international body. So the each manufacturer, the manufacturer who manufacture the LAN card, who manufacture LAN cards, so to these manufacturer LAN cards, they buy a portion of MAC address space. Okay, so that it assure uniqueness. Okay, for example in Asia region, okay, for example we have the HP or Flana or it is someone else, so each manufacturer they have a portion of MAC addresses. So for example, if a manufacturer it has 100 MAC addresses, so if that manufacturer develops it 100 LAN cards, each LAN card will have its unique MAC address. But if want to develop 200 LAN cards, then the 100 MAC addresses they will be replicated. Okay, so its analogy is that like MAC address, it is like social security number, and the IP address is like postal address. So the postal address, it should be unique, but the social security number, it can be changed. Okay, so its scope is local. The MAC address, it is flat. We have already discussed this for portability point of view. So you can move from LAN card from one LAN to another LAN. So no problem. Okay. The IP address, it is not flat. The IP address is hierarchical. It is not portable. You cannot move. If you move from one network to another network, then your IP address should change, as we have discussed it in the network. The IP address, it depends on the IP subnet to which the node is attached. So if the machine moves from one network to another network, then it will get another IP address. But the MAC address, it will remain same wherever you move. Okay, the MAC address, it doesn't change. So it has portability, and the IP address, it doesn't have portability. It doesn't have portability. Why? Because if a machine moves from one network to another network, then its IP address change. Okay, but the MAC address, it doesn't change. Okay, so we have already discussed. So okay, the IP address, it is not portable. So now we are going to discuss through an example scenario the working of ARP. Okay, so as we have discussed the MAC addresses or the LAN addresses, now we will discuss ARP. What is ARP and how it works? So suppose this is a host A, and the application layer, it generated the message. The application layer passed the message to the transport layer. Okay, and transport layer passes the message to IP layer. So suppose A creates an IP datagram with the IP source A and destination B. So you can see that this packet, this host, it has IP address 111.111.111.111. So this is the IP source, and IP destination address, it is 222.222.222. So this is the IP. So the IP layer, it will determine that this packet has to move over this path. Okay, this is its functionality, routing its functionality, and it computes the path. So it is also the responsibility of IP layer that this packet should be moved to first this router, to next hop this router. So the next hop, it is identified by IP layer. So IP will identify that this packet is moving from the IP address 111.111.111 toward the destination .222.222.222. But this message, it should be first moved to this router, to this interface. Next hop is this. So this IP layer says that this message, it should be moved next hop to this interface. This is its IP address. Okay. Now the IP layer, it passes the message to the MAC layer, the Ethernet layer. This is the link layer. So the link layer, basically it uses MAC addresses, as we have discussed. It uses MAC addresses. So the source MAC address will be the MAC address of host A. So host A, it knows its source address. This is its source address, so it is put here. Okay. But the MAC destination address, this packet, the network layer, it says to Ethernet layer that this packet should be forwarded to next hop. So the next hop is shown. So the destination address is next hop, this one, and its IP address is shown 111.111.111.111. So the MAC layer, it is told by IP layer that this packet should be moved to this interface. So this is the destination MAC address. But the IP layer, it tells the IP address of next hop. The IP address, you can see 111.111.111.110. But the MAC layer, it needs the MAC destination, the MAC address. It needs the MAC address of next hop. The MAC layer doesn't need the IP address of next hop. It needs the MAC address. So the A doesn't know the MAC address. It knows IP address. Why? Because this IP address, it is told to the Ethernet layer by the IP. So IP informs to Ethernet layer that this packet, it should be moved to next hop, and the next hop is one as identified by IP address. But the MAC layer, it needs the MAC address of the next hop, not the IP address. Okay, so A doesn't know the MAC address of the next hop. Okay, so for this purpose, how to get the MAC address? So for this purpose, we use ARP protocol. For this purpose, we use ARP protocol. Okay, so Ethernet will store this message. It will buffer this message, and Ethernet will create an ARP query. Another message. This is another message. It is generated by who? By Ethernet. Ethernet by A. So ARP query message is generated. The MAC source address will be the MAC A address. The MAC source address, because this message is generated by host A, so the host A MAC address, it will becomes the MAC source address of this message, ARP query. You can see it 74299CE8FF55. This is the MAC address of A, Ethernet address of A. And the MAC destination will be broadcast, because it doesn't know that, because it will be sent to all the nodes in the lane. it will be sent to all the nodes in the lane. Okay, so this is the host A. It generates a ARP query message with the source address of host A itself, and the make destination address is FF. And this query address is what? This query address is means, this ARP query means that this host A is looking for the MAC address of IP address 11111111110. Why? Because this is the next hop. Okay, so this A wants to forward the message to this next hop, but the A forwards this message at the data link layer using MAC addresses. Okay, so host A needs the MAC address of this IP, so it will sends the query for IP address this. Okay, so ARP query means that this host A is looking for the MAC address of this IP address. So the MAC destination address of this message is broadcast. It is for everyone in the lane. Okay, now this message is broadcasted over lane. It will be received by this node. This node will accept the message. Why? Because the destination address broadcast, it is for everyone on the lane, everyone on the link, so it will accept it. It will see that this ARP query is for IP address this 111.111.111.110, and its IP address is 111.111.111.112. So this IP address is not matching with its IP address, so it will discard, because this query is not for me, because this system will say my IP address is 111.111.111.12, and the query is for 111.111.111.110, so it will discard. This interface, it will receive the message, it will accept, because the MAC destination is FF, so it is for everyone on this lane. So this interface is also on this lane, so it will accept it. Then it will examine the query, that this query is for IP address this, so and its IP address is also this one, so its IP address is matching with this IP address in the ARP query, so it means that it is for this interface, so this interface will respond. Okay, so this ARP, so this message, this interface will respond for this ARP query, so how it responds? Basically, this interface, it will generate an ARP response message, and this ARP response message, it will be sent by this interface. So the source address of this message will be the MAC address of this interface. So MAC address of this interface is E8 E9 0017BB4B, so it will be put here. And the destination address is, because this message was received from A, okay, so the A MAC address will become the destination, so it is not broadcasted, but it will be sent directly to this. Okay, so the ARP response is sent to the one from whose request is received. So request is received from A, so it will be sent to A. Okay, so the A address, MAC address, will become the destination MAC address. And the response message contains what? The response message contains that this is the IP, okay, and this is its MAC address. So the MAC address of this IP address is this one. The IP address this 111.111.110, it has MAC address E8 E9 address. So this is the ARP response, and it will be sent to whom? It will be sent only to destination from where the request has come, from where ARP query has arrived. So ARP query is sent by A, so this ARP response will be sent to the A. Okay, so it is not broadcasted. So when A receives the ARP response message, it is received by A. Okay, so A will get the MAC address of IP. So this MAC address will be copied to here. It will be copied here. Okay, you can see that the MAC address from this ARP response, it is copied here. Now the packet is completed at the MAC layer. MAC layer it has make source address and make destination. Now this packet can be transmitted. Okay. So now this packet will be transmitted. But one more thing, that when this ARP message is received, its one copy will be stored in ARP table. This ARP response, its one copy will be stored in ARP table. So ARP table contains that for IP address this 111.111.110, its MAC address is this one. So it will be stored, and its time will be stored that it is valid for 20 seconds. Okay. So we will say that why it is stored in ARP table, so that if this node wants to send another packet, so when Ethernet layer receives another packet and it is for this IP address next hop, okay, so it will not execute the ARP, but it will get the IP address directly from here. So it will not send the ARP query and it will not get ARP response. So the waiting time is reduced. The message will not be sent. So the load on the network is reduced. So therefore, from when ARP response message is received by A, so A will store this IP and its corresponding MAC address in the ARP table. Okay. Why it is stored? So that if second packet comes, then for second packet ARP message will not be executed. The MAC address will be get from the table directly. Okay. So after this, you can see that this message is completed at Ethernet layer. Now the Ethernet layer will transmit it. Okay. So the message is now received here. So when the message is received here, so at the IP layer, what does it will do? The IP address is 111.111 and the destination is 222.222.222.222, and here its IP address is 111.111.110. So it means that this packet is not for this node, but this packet is for this destination. So this router will forward it further. This router will forward it. It will forward it. Suppose it forward it and it sends it on this interface. Okay. Suppose it wants to forward. So it wants to forward. Now it says that okay, the IP layer it will say that this packet, its source address, it should be sent to this node, and the next hop is 222. It is accessible directly. So the next hop is 222.222.222. Okay. So this is determined by IP, that this message it should be sent from here to here. Okay. So the IP source is, this message is generated by A. So IP source is same, and this message is for this node. So IP destination will be remain. But this router it has table, and from this table it will come to know that this message should be forwarded to this directly. So the next hop is 222.222. Okay. Now again, the IP layer informs Ethernet layer that this message should be delivered to next hop this. And Ethernet layer or the MAC layer, we use MAC addresses. So MAC source address, it is known. This will be the source. This is the sending device. So its MAC address is this one, 1A23F9CD069B. It will becomes the source address. And the MAC destination address, again it is unknown. Its MAC address is unknown. Why? Because the IP layer informs that this is the next hop. So the IP layer informs about IP address, not the MAC address. Okay. So how this node should get the MAC address of this next hop? So we will use ARP messages. Again, ARP query messages generated. This time the MAC source address is this one, and the destination will be FF because it is for everyone. And the query is for IP address 222.222.222 because this is the next hop. So this is this means that this node is looking for the MAC address of IP address 222.222.222.222. Okay, it will be broadcasted over the lane. It will be received by this node, by this node. This node will accept the message. Why? Because MAC address is FF, so it is for each and every one. But when it looks at this ARP query is for the IP address this 222.222.222.222, but this node it has the IP address 222.222.222.221. So this IP address is not matching with its IP address, so it will discard that this message is not for me, because this I don't know the MAC address of this IP. Okay, it's only know the MAC address of itself, its own IP. Okay, so it will discard. But this node it will accept. Why? Because this IP address is matching with its IP address. Okay, so it will accept, so it will respond. And how it will respond? It will generate ARP response message. Okay, so the ARP response message is generated, and the ARP response message it will be directly sent to this interface. So the destination address will be this interface, and the source address will be the MAC address of this interface, because it is at the Ethernet layer. Okay, and in the ARP response it will store that for this IP address the MAC address is this one, so its own MAC address is stored here, and this ARP response message is sent to this interface. So when this interface it receives the ARP response message, so this MAC address will be put here as a MAC destination address. Okay, you can see it. Okay, and also, okay, it will put here, and also this MAC address will be stored in the ARP table as well, so we have discussed it in the previous step. Okay, so now the message is completed. The source address and the MAC destination address is computed by using ARP message, ARP protocol. So the packet is now complete. So now Ethernet will transmit this packet. You can see it. This message is transmitted and it is received. So we have discussed the working of ARP. So I think it is much clear. Okay. So this message is received. Okay. Now we are going to discuss again. And suppose this host A, it sends another packet. And another packet when it sends, okay, so it is from the source address A, and IP destination is 222.222.222.222. So this is for B. So this IP layer will compute from its table that this message should be forwarded to the next hop this. So the next hop is this one, and this next hop it identifies the IP address that it should be sent to this IP address as a next hop. Okay. So the MAC address it comes to know about this. So now MAC address has to find the destination MAC address, but the network layer informs about IP address. So the MAC layer it will find the MAC address for this next hop. Okay. So how it finds? So as we know that already there is ARP table, so it will looks in the ARP table. So in ARP table for this IP address its MAC address is stored, because we have computed it in the previous step. So it is stored, so it will be copied here. The ARP protocol will not be executed. So this is the advantage of ARP, that the time is reduced, the delay is reduced. Why? Because ARP, if there was no entry in the ARP table for this IP address, then it will send the ARP query message, then the ARP response message will come. So it will take some time. So this time is reduced. Second, when the ARP query message is sent and the ARP response message is received, so it creates transmission. So this transmission it uses the bandwidth. So the bandwidth is wastage is avoided. Okay, so it will get the MAC address from this table directly. You can see it. This MAC address is put here. So now the message is completed. Okay, so the message is completed and now the message will be sent. So when this node it receives the packet, so this packet is from IP source 111.111.111.111, and the destination is 222.222.222.222. Again it will find in its routing table that this message should be forwarded to this link. Okay, so you can see that now this IP layer, it informs that this message should be delivered to next hop this node. Okay, so it will informs the make layer. Again, the make layer, it has the source MAC address of itself, and the destination address, the next hop, its IP address is present, its MAC address is not present. However, the Ethernet requires MAC address. So how it will compute? So it will first consult its ARP table. So in ARP table already the entry is stored, so it will get the entry from here. Okay, so the message is completed now. Okay, the message will be sent. Okay, so we have explained that how ARP protocol works. Okay, so we have discussed that how to determine the interface MAC address knowing its IP address. So we can do it by using ARP protocol, and we have discussed ARP. The question is how to determine the interface MAC address knowing its IP address. For example, in this figure, we know from this figure we know the IP address, but we don't know the MAC address of next hop. So how we compute it? By using the ARP message. Okay, so first of all, it will look in its ARP table. If there is no entry, then the ARP message will be executed. If there is entry, then that MAC address will be copied as the MAC destination address. Okay, so we have explained the ARP message in detail. Okay, so in each node there is a ARP table. Okay, there is a ARP table. In each node there is ARP table. For example, here you can see it, there is ARP table at this node. It stores the IP address and its MAC address, corresponding MAC address. This is the IP address of interface, and this is the MAC address of that interface, and this is the time to leave. That this entry is valid for 20 seconds. When 20 seconds expires, this entry will be removed from the table. Okay, so there is at each node there is an ARP table. Okay, and it contains IP MAC address mapping. That for IP address, this is the IP address and this is its MAC corresponding, and this is the time to do. For example, 20 minutes 20 seconds, that after this time the entry will be expired. Okay, so how ARP protocol works? So we have discussed it through examples. Okay, how it works. So basically, if A wants to send a datagram to B, so B's MAC address is not known and it is not in the ARP table, then A will broadcast ARP query message. So the destination MAC address will be FF. So it will be accepted by all the nodes in the lane. Okay, so when B receives the ARP message, so it will send the response. When this response will be sent unicast directly to A. Okay, it not be broadcasted. And when A receives, so A will copy the MAC address in the packet, and it will also store this in the cache. So A caches are saved the IP to MAC address pair in its ARP table. So it store the MAC address and IP address that is received in the response message in its cache. Okay, so the timeout is set so that the entry is not remain forever, because the nodes they move. Okay, in some network you can know it. For example, if this you can see that, for example, here this network, if it is laptop, so maybe the user move from here to here. So if the nodes moves and still this entry is maintained, for example, okay, for example, you can see its MAC address and IP address is maintained. So if this node move from here to here, okay, so if this and this entry is maintained, then and the packet arrives here for IP address this, then this packet will be transmitted. But here there is no B, so it will not be received by anyone. It will be discarded. So therefore, this timeout is set like 20 seconds. After 20 seconds, the entry will be expired. Okay. So we have discussed ARP in detail. Next we are going to discuss the Ethernet through in examples. Okay.